Hi guys, this is Dr. G here, and in this particular video we will talk about chapter 4, which is on atoms and elements. So chapter 4 is actually from your textbook for CHM 104, which is Introduction to Inorganic Chemistry. And I actually like to start CHM 104 from this particular chapter, mainly because this will be the most important chapter for your exam 1. Okay, so in this chapter, the first thing that we are going to discuss is the term called elements. So in this particular slide, we will try to define the term called elements. So elements are actually primary substances. They are the primary substances from which all other things are built. So basically the things that you could see, feel, touch, smell, all of these substances are primarily made up of these units called elements. And the most important thing about elements is that they cannot be broken down into simpler substances. So elements cannot be broken down into simpler substances. And usually elements, there are lots of elements in nature. Okay, in our surrounding, in our nature, there are lots of elements, approximately hundreds of elements. Okay, so basically if you when you have around 100 different elements, okay, so using them by their name could somewhat be challenging. Okay, so therefore sometimes we try to use symbols to identify elements. Okay, so that is like a nickname for every element. Okay, so every element has a symbol. Okay, every element that is found in nature or that is present in something called periodic table has a symbol. Okay, and these symbols of elements are usually 1 to 2 letters. The symbols of elements are usually 1 to 2 letters. Okay, and they are abbreviations to symbols. Okay, they are abbreviations to the names of the elements, and these elemental symbols usually have 1 to 2 letters, as I mentioned earlier. And the first letter is always going to be an uppercase letter. The first letter is always going to be an uppercase letter, or it is capitalized. Okay, and if there is a second letter, okay, sometimes there could be a second letter. So if there is a second letter, it is always going to be a lowercase letter. It is always going to be a lowercase letter. So here are some of the examples. Okay, elements such as hydrogen, carbon, boron. Elements such as hydrogen, carbon, boron. These elements have only one letter elemental symbols. Okay, so these elements such as hydrogen, carbon, boron, they only have a one letter symbol. But sometimes you could have elements such as helium or calcium. They have two letter elemental symbols. They have two letter symbols, and of course the first letter is capitalized and the second letter is lowercase. Okay, so the first exercise that I want you to do is to print a periodic table. Okay, you may find a nice periodic table from an online source, or your textbook has a printable periodic table. Okay, so first thing that I want you to do is print this periodic table and try to familiarize the elements that are present in a periodic table and the symbols for each of these elements. Okay, the symbols for each of these elements. And here's the thing, I am not asking you to memorize all the elements in the periodic table. Okay, don't get me wrong. I am not asking you to memorize all of them. I just want you to be familiar with it. So in the exam, okay, one of the very common questions that I ask is, I will give you an element and I will ask for the symbol of that particular element, or vice versa. Okay, so you simply have to, like, find it from the periodic table, because periodic table is going to be allowed in the exam, so you can easily read it from the periodic table. But here's the thing, if you have never seen a periodic table or used it, you're going to have a hard time in the exam. Okay, so basically I want you to see familiarize yourself with the periodic table and see if you could figure out different elements that are present in a periodic table, and of course their respective symbol. And when you are trying to familiarize yourself with the periodic table, try to look at elements such as sodium, potassium, lead, tin, or things like silver or mercury. Okay, uh, try to look at those elements specifically, mainly because their element name and symbol are not very related. Okay, so as an example, if you take a look at sodium, okay, if you take a look at sodium, sodium has an elemental symbol of Na. Okay, so potassium has an elemental symbol called K. Lead, Pb. Silver, Ag. Gold, Au. Tin, Sn. Okay, but I mean the elements, I mean, some of the elements in the periodic table can have symbols that are not very related to the name itself, mainly because these names of elements could be from different languages. Okay, it could be from different languages, so therefore the symbol and the name could be a little bit different. So these are some of the primary examples: sodium, potassium, lead, silver, okay, tin. These things are primary examples, and there are few more. Okay, pay attention to them. But most of the elements have a abbreviated symbol which is very similar to the name, such as calcium. Calcium is Ca. Sulfur, S. Oxygen, O. Nitrogen, N. Magnesium, Mg. Barium, Ba. As you can see, most of the times the elemental symbol is the first or the first two letters of the name itself. Okay, so it is a nice abbreviation, but there could be exceptions like these. Okay, so the first thing that I want you to do is try to familiarize yourself with different elements that are present in the periodic table that could come in handy in an exam environment. Okay, all right. So next, we are going to talk about the next slide. I mean, in the next slide, I have given you some of the examples for common elements. Okay, some of the naturally find compounds and their respective elements. Okay, so of course, if you take this pennies, okay, I mean, here's the thing about pennies. Okay, usually pennies that are after 1980s are not copper, but if you find old pennies, okay, old pennies like pre 1980 pennies, okay, they're actually made up of copper. Okay, they are actually made up of copper. Of course, nowadays copper is an expensive metal, so therefore, if you make a penny out of copper, it is going to be more expensive than a penny. Okay, so usually pre 1980 pennies are actually copper. Okay, and of course these aluminium trays, they are made up of the element called aluminium, and nickel is made up of the metal called nickel. And here's a question for you. Okay, so I have the element carbon, and then an example I have is a pencil. Okay, it's a pencil. Where can you find carbon in a pencil? Where can you find carbon in a pencil? You might want to pause the video and see if you could answer this. Where do you find carbon? If your answer is wood, okay, the wood part, that is correct, because I mean wood is a plant-based material. Okay, and then of course plant-based materials are usually what? Carbon, nitrogen, and oxygen. Okay, so plant-based materials are mostly carbon, nitrogen, oxygen, and hydrogen. Okay, so these are the elements that are commonly present in the wood part of the pencil. But there is a part of the pencil that is 100% or almost 100% carbon, which is actually the tip of the pencil. This black color part, we call it lead. Okay, lead of the pencil. Actually, it is not lead. Okay, lead means Pb in the periodic table. Lead means Pb. Okay, but the pencil lead is actually 100% or approximately 100% carbon. Okay, it is 100% carbon. Okay, so actually carbon is one of the most common elements to us, okay? On Earth, most of the things are made up of carbons, okay? So that is why there is a whole new area called organic chemistry in chemistry. Organic chemistry mostly talks about carbon chemistry, okay? So, yeah, that is a nice example for carbon, okay? Pencil lead is 100% carbon or close to 100% carbon. How about diamonds? How about diamonds? What is the element that makes diamonds? Diamonds are, of course, carbons, okay? If you have a piece of diamond, okay, that is also carbon. Actually, it is almost 100% carbon, okay? So basically, a diamond, piece of diamond and the pencil lead both have almost 100% carbon. So, I mean, they should work the same, right? Actually, no. Diamonds are extremely expensive, as you know, but pencil lead is very cheap or inexpensive. And diamond, even though it is 100% carbon, it is the hardest material on earth, okay? It is the hardest material. So most of the drill bits are carbon. Why? Because that is the hardest one. Carbon can scratch anything, okay? Carbon is very hard, it can scratch anything. But a pencil lead, can it scratch anything? Probably not. I mean, it couldn't even scratch a piece of paper. I mean, when you are writing from a pencil, it tend to stick to the paper. That is why it leaves a trace. Okay, so even though they are the same element, basically they are both carbon, but the material diamond and the material pencil lead or graphite, we can say, they have totally different characteristics, mainly because of the atomic arrangement, okay? How the atoms in that particular material is arranged, okay? But I mean, we will talk about these atoms and their arrangement in much more detail in chemistry, okay? For now, just learn that, okay, there is a term called atoms. We will talk about it in more details later on, okay? But the arrangement of these carbons are different in lead or graphite and diamond. That is why they have a huge range in price point and also huge variance in their properties, okay? All right, so here's the thing. In early 1800s or in early centuries, okay, we didn't know many elements, okay? We only had a handful of elements, and then there is no real need for categorizing those elements, right? It is like, when you have a few books, why do you need to categorize the bookshelf, right? So you can just lay them on a table and you can easily access the books that you want. But with time, let's say you go to college, and then with time you accumulate lot of books, like science books, math books, English books, so many books, right? And then then you have to categorize those books, right? So basically, periodic table is, you can say, a glorified categorization of elements, okay? If someone asks you what is a periodic table, it is like a bookshelf, okay? It's a nice categorization of elements. In early days, we didn't have many elements, so we didn't have to categorize them. But with time, we learned, or we found, or we discovered new elements, and the number of elements that are common to humans grew. And then not only that, we noticed, or scientists noticed, that, okay, certain elements are similar in properties, okay? It could be physical or chemical properties, but they are similar. But certain elements are actually highly distinguished from each other when it comes to chemical and physical properties. So based on the chemical and physical behavior of elements, okay, chemists started to categorize elements, okay? A Russian chemist called Dmitry Mendeleev, okay? He's the first scientist to suggest that elements could be arranged in groups of families, okay? So based on their similar properties, chemical and physical properties, you could arrange elements in different groups, okay, according to their similar properties. And today we call this arrangement of elements periodic table, okay? So today we call this arrangement of elements periodic table. It is just like a bookshelf, guys. It's just like a bookshelf. Let's say, with time you accumulate English books, science books, and then math books, right? So you categorize them according to these are my science books, these are my math books, and then these are my English books, right? So periodic table is just a table that categorizes elements, okay, that categorizes or arranges elements, okay. And here's the thing, okay. Let's take a nice example table, okay. Let's take a nice table for an example. So let's take an Excel table, okay. So in Excel, everyone is familiar with Microsoft Excel, right? So this is how Excel tables look like. Pardon my poor drawing habits, okay. And this is an Excel table. Let's say in Excel tables, okay, you have what? You have rows and columns, right? So basically these horizontal rows, we call them rows, okay. And then you also have these vertical columns, and we call them columns in Excel. So these are your columns. And of course in Excel, they use the alphabet to identify different columns, and of course they use Arabic numbers to identify different rows, if you're familiar with Excel, okay. But I mean, the difference between periodic table and a regular Excel table is not very large, okay. They are very similar actually. The primary difference is that in let's say in chemistry, rather than calling these vertical structures columns, we call them groups, okay. Vertical columns are known as groups in the periodic table, and rows are known as what? They are known as periods. So horizontal rows are known as periods and vertical columns are known as groups in a periodic table. That is the primary difference between a regular Excel sheet or a regular table and then the periodic table, okay. Groups and periods, okay. That is the primary difference. What's going on? Excuse me. So sorry about that. So basically in the periodic table you have these things called groups. Remember these terms, they are very important, okay. You have these things called groups and periods. Groups are nothing other than vertical columns. Groups are vertical columns, and periods are known as horizontal rows. Okay. So here's the thing, why do we need these periods and periods and groups, okay. We basically need those periods and groups to identify elements. Right? So in Excel, what do you do in Excel? Okay, so in an Excel sheet, okay, if you want to access a certain cell, if you want to access this cell, okay, what do? You basically identify it using the column label and the row label. So this will be what? B4. Okay, so basically by using the group numbers and row numbers, you can directly identify each cell, and this will be what? This will be C4. Okay, by using the column number and the row number, you can easily identify each cell. And also in chemistry, by using this group number, and period number, you can easily identify different elements. And here's the most important thing, okay. Groups, which are basically vertical columns on the periodic table, okay, and these groups basically contains elements with similar properties, okay. So each group contains elements with similar properties. That is important to remember. And periods, okay, which are basically horizontal rows in the periodic table, they contain elements with the same number of electron shells. Don't worry about the electron shells yet, because we will talk about in electron shells in more detail later on, okay. But for now, just remember that in a periodic table, Vertical columns are known as groups and horizontal rows are known as periods, and by using the group numbers and period numbers you can identify each and every element very easily. And here is an example, guys. Here is an example. Okay, so once again, vertical columns are known as groups. Okay, so these right here are group numbers. These are group numbers. And for the first look of the group numbers, as you can see, group numbers basically have a Roman letter. Okay, Roman letters are basically what, using I V X. Those are the common symbols that we use to identify Roman numbers, right? So you basically have a Roman numeral. Okay, this one is VI, that means it is 6. Okay, and then Roman numeral is followed by either A or B. Okay, so as you can see, in group number you always have a Roman number followed by either the letter A or B. That is how you used to identify group numbers or vertical columns. Okay, and period numbers are numbered very easily by using Arabic numbers. Okay, so these right here are your period numbers or horizontal rows. They are numbered using Arabic letters. So what is the significance of using this letter A or B? What is the significance of using the letter A or B in the group number? Okay, what do you think about it? What do you know about it? Why do we need this? If you look at this A and B, I have highlighted them in red, and then if you have letter A next to the group number, we call it representative elements. If you have the letter A. Okay, if you have the letter A next to the group number, we call it representative elements. If you have the letter B next to the group number, we call it transition elements. So what is the difference? Between the two? Why are they different? Why do we call them representative or transition? And here's the difference. Okay, they are the difference of representative elements and transition elements are like apartments. Most of you might have the experience in renting an apartment by now, right? So you go to an apartment complex and you find the resident manager, and once you find the resident manager, you will explain this lady, okay, I wanna rent an apartment, so can you please show me an apartment, right? So she's like, okay, very nice lady, right? She will take you upstairs and then show you a very nice apartment. Okay, everything is very nice. The walls are nicely color washed, there are perfectly sized furniture, very clean. You go to the bedrooms, they have nice beds with nice beddings, and also you go to the bathroom, it is squeaky clean. Everything is nice and smells nice. You are like, oh my god, this is an excellent value for the price, I want to rent this apartment, right? So you are like so happy with this apartment. You want to like, oh my god, I want to move in today. How much is the apartment? So you are ready to pay, right? You are ready to like sign on the dotted line. And she was like, don't rush, let's go downstairs, let's talk the numbers. Okay, so you go downstairs and talk the numbers with the lady, and then you sign. You're so in rush to sign, and then she will give you the key. Here is your own key. Okay, and then you try to go upstairs and go to your dream apartment, and she was like, no, don't, no, this is not your apartment, this is our model apartment, this is not the one that you are getting. Okay, your apartment is actually at the back. It basically has the same exact floor plan. You will really love it. She's like, go all the way to the back and you will find the apartment. And then you drive all the way to the back of the apartment complex, hoping to have your dream apartment. You turn the key, open the door of the apartment, and oh my god, the things that you see, The carpets are filthy. There is no furniture in this apartment, and the walls have drawings, and the fan has an underwear, circling around. This is nothing like what you saw in that apartment. You rush to the, resident manager's office, and you were so mad. You were like, this is not what I saw. This is not the same apartment. She was like, no, this is the same exact thing. It has the same exact floor plan, even though it doesn't have the view and everything, but it's the same floor plan, it's the same square footage, so you will love it. But you got fooled, right? So elements are like that. Representative elements are like this model apartment. Resident manager knows exactly what to expect from these model apartments, and then we know what exactly to expect when it comes to representative elements. Okay, they are highly predictable. We can easily predict their chemical and physical properties. They are highly predictable. They are very easy to predict. And then transition elements are like the apartment that you get. Okay, they are highly unpredictable. Okay, they could be completely different from their neighbors, and then they could have completely different chemical and physical properties, so they are hard to predict. So we call them transition elements. So in chemistry, the first two groups and the last six groups, first two and the last six, okay, a total of what? Total of 8 groups. These 6 plus 2 groups are called representative elements. So any element that you have in the last 6 or the first 2, those elements are known as representative elements. Okay, and the elements that you have in the middle, these elements right here, we call them transition elements. Okay, so in the exam I will ask you, what type of elements do you see in the second group number 2A? Of course they are representative elements, because the first 2 groups are included in the representative elements. And sometimes we break these representative and transition elements into more categories. Okay, the first 2 groups are known as S block. Okay, so the first 2 groups are known as the S block, lowercase s, and the last 6 groups are known as the P block. Okay, so S block and P block combined, we call them representative elements. And then you have the D block and the F block. Okay, so D block and F block is known as, combined, they are known as transition elements. Okay, transition elements. So those are the elements that are present in the periodic table. So I hope I made myself clear. Okay, so let's look at an atom like carbon. Okay, so if you highlight an atom like carbon, okay, carbon is in what? Is in group number 4A. So the carbon group number is 4A. And then of course the period number for carbon is 2. Okay, so by using the group numbers and period numbers, you can easily identify each of the elements. Okay, all right. Okay, so for now, at home, I want you to use this periodic table or the one that you have in the textbook. Familiarize yourself with the element name and the symbol, and then maybe try to figure out their group number and period number. Okay, maybe try to figure out their group number and period number respectively. Okay, I think I have a few worked examples later on. Okay, and sometimes some of these groups that you have in the periodic table are very dear to chemistry people, and they are very common. Okay, so we try to call these groups by nicknames. If you take group number 1A, okay, in group number 1A you have elements such as lithium, sodium, potassium, rubidium, cesium, francium. Okay, so these are the elements that are present in group 1A. So we call group 1A alkali metals. Okay, alkali metals are the classification or the nickname that we use for group 1A metals. And group 2A metals, elements starting from beryllium, magnesium, calcium, strontium, barium, radium. So group 2A metals are also known as alkali earth metals. So if someone asks you to name an alkali earth metal, you can name anything starting from beryllium through barium. Okay, halogens are also a very common group of elements for chemistry people. So halogens are usually halogens are known as fluorine, chlorine, bromine, iodine, and astatine. Okay, so these are the most these are the halogens in the periodic table, and then they are actually present in group 7A. So group 7A metals, group 7A elements are known as halogens. And the next one is very common to most people, noble gases. Okay, the classification noble gases is used to identify group 8A elements. Okay, so these noble gases or group 8A elements are highly inert. They have a very low chemical reactivity. Mainly because they have very stable electronic arrangements. We will talk about it later. And they are odorless, colorless, and that is why we call them noble. It is like in Chinese movies, you always have this noble one, and then everyone else wanna be like the noble one. So in periodic table, okay, you have these noble gases at the end of the periodic table, and then every other element wants to be like the noble gases. Okay, so that is why we see a lot of chemical reactions and chemical compounds. Okay, so these noble gases are extremely stable, so they are the noble ones in the periodic table, and then every other element wants to be like the noble gases. Okay, so these are some of the classifications that we use in chemistry to identify certain groups: alkali metals, alkali earth metals, halogens, and noble gases. Okay, and this slide was put in here accidentally. Okay, I will have this slide again in a later we will find this slide later on. Okay, so I'm not going to worry about this too much, but of course I want you to understand the third bullet point if you can, but we will talk about this in more detail later on. Okay, for now, these group numbers actually tells you something. Okay, these group numbers are important. Okay, especially the Roman numeral part of the group number. Okay, if the element is in the representative groups, or if the group number has the letter A, okay, next to the Roman numeral, okay, usually they are known as representative elements, of course. And then the important thing about them is that we will talk about something called electrons, and then we will talk about the relationship to electrons and the group number later on. Okay, but for now you can ignore this slide. We will come back and talk about this slide in much more detail later on. Okay, and the last thing that we are going to talk about in this particular video are going to be metals and non-metals. Okay, metals and non-metals. So let me ask you a quick question. Don't look at the figure that you have at the bottom of this slide. Okay, answer me this question. In a periodic table, of course, you have about 100 different elements. Do we have more metals or do we have more non-metals? Which elements are more? Do we have more metals or non-metals? The most common answer that I get from my students is that they think that, okay, we have more non-metals in nature, so of course the periodic table should have more non-metals, right? Because most of the things that we see in nature are non-metals. Metals are so rare, that is why they are more precious. Okay, we don't hang around a chunk of carbon around our neck. Okay, maybe you do, because if it fits the diamond, you will. That's a bad example. Let's say we don't want to hang around a piece of wood around our neck, right? But of course we like to have some gold, platinum, silver, these type of metals, or we use those metals to make jewelries. Why? Because they are expensive. Why they are expensive? They are precious, they are rare, right? So metals are rare. Even though metals are rare, we have many different types of metals, or in other words, we have many elemental metals. Okay, so we have many more metals as compared to non-metals. Now we only have a few non-metals. Okay, the green ones are the non-metals. Okay, and as you can see, we have only a very handful amount of non-metals. Okay, especially the noble gases. Okay, these are the noble gases: helium, neon, argon, krypton, xenon, radon. Okay, this is missing a letter, I just noticed it. Okay, anyway, the noble gases are, of course, they are gases and they are non-metals. Noble gases means the name itself says that, hey, they are gases, so they better be non-metals, right? Because you don't find gaseous metals. There are no gaseous metals, so these are definitely non-metals. And then, of course, hydrogen is a non-metal. You knew that. And then you have non-metals like carbon, nitrogen, phosphorus, oxygen, sulfur, tellurium. And then, of course, things like fluorine, chlorine, bromine, iodine. Those are non-metals. And astatine. Those are non-metals. Okay, so these are the only non-metals, I mean, in total, which is less than 15. Okay, maybe I have never counted it actually. So we have 6, 5, 11, 14, 15, 16, 17, 18. So 18 non-metals. So we have 18 non-metals in the whole periodic table. And then everything else is what? Everything else is a metal. So we have more metals than non-metals in a periodic table, even though metals are rare. Okay, so you have more metals than non-metals. And why do we call certain elements metal and certain elements non-metals? Because of their characteristics, because of their physical and chemical properties. Okay, and also not only metals and non-metals, you also have a group of elements called metalloids. Okay, you also have a group of elements called metalloids. So the elements that are in magenta. Okay, so these are your metalloids. Okay, they have both metal and non-metal characteristics. That is why we call them metalloids. Okay, they are basically like amphibians. Okay, so basically they have both the metal characters and non-metal characters. Okay, so we only have seven metalloids. So I highly recommend you to memorize these. I highly recommend you to memorize these non-metals. Okay, so please memorize them because you don't have very many. Okay, so boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Remember these 7 metalloids. That is important. And then anything that you have to the left side, to the left side of the periodic table are going to be metals. So you memorize the metalloids, and anything that is left hand side of the metalloids are going to be metals. Of course, the exception is hydrogen. Okay, and then anything to the right hand side are non-metals. Okay, so that is how you easily, in the exam I will give you a random element and I will ask you, is it a metal or a non-metal? So to answer those questions, you might want to remember the whole periodic table, or you might want to remember the 7 metalloids, and then if the element is to the left hand side, it is going to be a metal. If it is to the right hand side, it is going to be a non-metal. Okay, very important to understand that. And then the other important thing that I want to talk about are the properties of metals and non-metals. Okay, properties of metals and non-metals. So metals are usually what? They are very shiny and they are solids. They are very shiny solids. But there is a liquid metal. Okay, there is a liquid metal in the periodic table. Okay, what is the only liquid metal at room temperature? What is the only liquid metal at room temperature? That is mercury. You might have seen it in old school thermometers. Okay, in old school thermometers, okay, they have this shiny silver color liquid that is going up and down in the thermometers. Okay, so that liquid is actually mercury. Okay, that liquid is actually mercury. So that is something important to remember. Okay, at room temperature there is only one metal that is liquid, and that non-metal is actually mercury. And they are usually shiny solids except for mercury, which is a shiny liquid. Okay, they are very heavy, so their density is very high. Okay, they are, even a small piece of metal is heavy. Okay, so their density is very high. Okay, and also they are good conductors of heat and electricity. Okay, they easily conduct heat and electricity. Imagine a pan, okay, a frying pan. Usually the frying part of the pan, okay, the frying part of the pan is a metal. Why? Because you want to transfer heat from the bottom of the oven to your food, right? So you want to transfer heat from the burner to your food. Okay, so the frying pan should be able to transfer heat, so it should be able to conduct heat from the burner to the food. Okay, so you use a metal. Why? Because it will conduct heat from the burner to the foods. Okay, and then the handle of the frying pan is usually a non-metal, something like a rubber or a wood piece, right? Why? Because you don't want to have you don't want to get burned by handling the frying pan. So that is why you need something that is not a good uh, heat conductor to be your handle, right? And also, if you imagine an electrical cable, okay, of course the outside or the plastic covering of the electrical cable is not going to conduct electricity, so you can easily touch the wire and then you will not get electrocuted. But of course the middle part of the electrical cable, okay, that is a metal. Okay, so that is conducting electricity. So basically metals have very loose electrons. Okay, so when you provide a potential difference, you can actually move these electrons in the metals from one side to the other. Okay, so it can conduct electrons, so they are good conductors of electricity. Okay, and they are very hard to melt. Okay, very extremely hard to boil. If they are hard to melt, it should be even harder to boil them, and it is almost impossible to boil them. You need very high temperatures, and metals are easily malleable. Okay, that means you are able to hammer it into nice shapes, okay, without breaking or cracking. Okay, if you have a piece of metal, you can easily hammer it into a nice piece of equipment or piece of jewelry or something like that. So they are malleable and ductile. Okay, so those are the properties of metals. Okay, those are the properties of metals. So non-metals are basically opposite to metals, so they are not malleable. You can't hammer it into nice shape, or you can not make a thin wire out of non-metals, and they are not very shiny. They are dull, earthy. Okay, and they are very poor conductors of heat and electricity. Okay, and they have usually low melting points and densities. Okay, they have low densities, so they are lightweight, and they have low melting points. So some of the non-metals are even gases at room temperature. Okay, and few could be solids. Okay, things like carbon, phosphorus, sulfur. Okay, and iodine, silurium, those are solids at room temperature. Of course noble gases are gases at room temperature, so these are gases. And then you have actually one liquid non-metal at room temperature. You actually have one liquid at room temperature, one non-metal liquid at room temperature. What is that? It is bromine. Okay, bromine is the only liquid non-metal at room temperature. Most people go for chlorine because they think that, okay, the bleach that people use to clean laundries, or things like that, those are liquids, so chlorine should be a liquid. No, actually chlorine is a gas at room temperature. You put chlorine into water, that is how you make these bleaches. Okay, so chlorine is a gas, but bromine is a liquid. It is similar. I mean, I mean, you know, chlorine liquids smell bad. Okay, some people are even allergic. Bromine is actually the same. Okay, it smells bad and it has a vigorous smell, highly volatile. Okay, and it's a brown color liquid. So that is the only liquid non-metal at room temperature. Bromine. Okay, so with that I'm going to conclude the lecture series for this video. In the next video I will talk about the term called atoms. Okay, so in the next video I will be talking more about the term called atoms, and then we will go on to discuss about the atomic subatomic particles, and we will also talk about more details on those subatomic particles, and then electrons, especially electrons. We will talk about the electrons in more detail. Okay, all right guys, and please note that there are a few study checks in this lecture note. Okay, you can try them at home, okay, and see if you could do them. All right, and please let me know if you have any questions. Okay, you guys have a good one. Take care, guys.